Hello Tube users. Today at work we have found a 40 15-inch Dell monitor. Bit ancient. CCFL backlight, none less LED, newfangled rubbish. But anyway, symptoms were the power supply was trying to start up. It was literally turn it on and that sort of motion, trying to kick in but wasn't. One of two things. One could be the CCFL backlight circuit, or most likely could be the bootstrap starter circuit. Generally a leaky capacitor. And when I opened this baby up, one of two things I found. One of two. That capacitor to the left is bulging, which may indicate, well, switching on and off. The other issue I found was this one is slightly bulging, this one's quite badly bulging, and this will be on the bootstrap circuit. So I'm going to attempt to repair this tonight. I'll do some more footage, so we'll see you then. I mean, I may replace a few of these capacitors anyway. They're shitty make, shame on you Dell. I'll replace them with some Rubicons just to be on the safe side. Bulk capacitor doesn't really matter, I can leave that as is, but I will test it anyway. And yeah, I'll come back to that later on today when I get home from work. Catch you then. Right then, back at home now from work, and this is the same board we looked at earlier. This is out of a Dell 15-inch monitor. Yeah, it's an old one, but as I say, original symptoms were kind of, it was trying to power up, it was trying to kick in, and it wasn't. Kind of click on, click off, click on, click off, click on. Now, as I say, it can be down to leaky capacitors, and obviously upon looking at the board, there's one there. That's slightly domed, that's flat, that's flat. So those two are toast, or near enough. And as I said, this is part of the bootstrap circuit, the switch mode power supply, which controls the amount of voltage on the output. So, given that, obviously these fall short, these fail short, so the capacitance go higher, and then the ESR of them also increases. So effectively, when they completely blow, they don't blow open like most components, like a resistor, say for example. Once they're burnt out, they blow open, therefore the connection's not made. These actually blow short, so it's like a direct connection between 2 points. So where the capacitor 2 pins are, it blows short, which means that that becomes a link in the circuit. So, and as we can tell from the symptoms of the problem we've got with this monitor in particular, it's obviously preventing the power supply from booting up essentially. And if we get a bit closer, I'll show you this blown capacitor. You can tell there, can you see that? Hang on, let me adjust this focus ring. There we go. See that one there? It's got a domed top on it. The one underneath it, the blue up front there on the right, doesn't seem to be too bad, but trust me, it's domed. And there was another component. Can you see which one's blown there? That one. You can generally feel these to get an idea. Yeah, slightly domed, but as I say, that can be enough to ruin your day, as Dave would say in the EEV blog. Oops, sorry. Let's focus again, shall we? There we go. Yes. So, as I say, we're going to attempt to repair on this board. So, this is a double-sided board and mostly has surface mount components on it. So it could be quite tricky to actually get those components out. For example, that one there, look at the negative pin, and you can see that's the negative pin there. There is a massive great ground plane that's attached to. So bearing in mind, when you're soldering, that is going to be one pain in the backside, because obviously it acts like a heat sink and will actually heat up this whole entire copper ground plane, which will then become a heatsink. So getting that component off there is going to be a bit of a pain, but I'll hopefully be able to show you that in the next video. So let's go and have a look, shall we? Well, it's a close-up of the board that I showed you earlier. Let's get my cup of tea out of the way. Yes, I'm a British tea drinker, not Irish or Scottish though. Yeah, so if you have a look here, can you see the top of that cap? It's bulgy. You can just make it out on the camera. See that one there as well? That is also bulgy, and that one is not. Best way to check these is what I do. Feel the top of them. That's nice and flat. Yeah, you can tell it's got a bulge, and that has got a really bad bulge in it. Obviously bulging capacitors denote the fact that they are either failing or have failed. They normally spew their guts. They've got like an electrolyte liquid inside them, which generally spill out over the top when they go completely. You can see the brown spot in the middle there. That is some of the electrolyte there. They can be quite worse if they spill their guts completely. Can actually come out all over the board and actually corrode the board, especially on power supplies or things that get hot, because as you can see in this power supply, like most power supplies, they tend to stick capacitors right next to heat sinks. Not such a good idea, really. So basically, if you find a piece of equipment or electronics that is either not functioning correctly or the problem seems to be intermittent, i.e. say for example a TV, if the backlight is flickering or tends to flicker, or the TV switches off randomly without the timer enabled obviously, then chances are it's a leaky capacitor, which is what we would call this situation right here. Or I mean, for example, you get TVs that tend to misbehave, shall we say, and after a little while the problem gets completely worse, i.e. the TV doesn't turn on anymore. So you might have, say, 3 to 6 months of it switching on, switching off, misbehaving, and then a little while longer it would just be completely dead. Most likely these are the culprit. So again, this is not a TV, it's a monitor, but same principle goes for also any electronic equipment. This is also another cap that I found. It's actually on the CCFL backlight circuit. That one's nice and flat, and it's slightly bulged. I will change that as a matter of course anyway. The other caps seem to be fine. I can't find any other issues on this board visible anyway. Quick tour. So this is a 15-inch monitor. This is a display driver, you can tell because it goes out to the display connector here. Power supply section, that's probably the transistor switching this transformer. Bulk capacitor, and do make sure you discharge those before you stick your fingers across the terminals. I can, because I know I've done it. Don't test it by sticking your finger on, by the way. It would hurt a lot, if not kill you. So kiddies, don't touch. Bridge rectifier there, smoothing cap, some filtering going on, another smoothing cap. So this is where the AC comes in. Obviously you can tell because the IEC connector is there. So, so you go AC in, obviously through the caps, filtered, bridge rectified, bulk capacitor, and probably the voltage output is around here. Into some more power supply stuff. Probably, as I said, the bootstrap circuit, which controls the amount of voltage coming out of the output. So that's a display driver end. You can tell because it's near the VGA connector up top, and the connector for the monitor screen itself. What else have we got? Yeah, CCFL backlight, you can tell by these two transformers here, which convert DC, which comes out from the power supply, to AC, and is taken out of these 4 connectors, as you can see. So yeah, these are quite dangerous. These output quite a high voltage. Not sure how much it is, but it is a lot. So again, if you're working on a TV and or monitor and the power is on, do not go anywhere near this end or this end. So really what I'm trying to say is, if you don't know what you're doing, please don't do it. Leave it to a professional or someone that knows what they're doing. Otherwise you could get a nasty bite out of one of those. So yeah, next we'll look at actual repair. And as I said earlier, might have a problem because this cap, the minus pin, is attached to the ground, which is a massive ground plane attached. So might be fun. Might have to set my soldering iron up to a higher temperature than usual to try and get that sucker off. If not, I think what I will do, worst case scenario, if I cannot get these off, I will just flip the board and then put the capacitor in backwards and solder it that way, or to the nearest terminal to wherever this capacitor connects to. But we'll see how it goes. We'll have a look in the next video.